Okay, so the question is did we also do the projectile moment question in the
Yes,
question two?
yes, we
Okay.
already solved that one. I will share that file again because we solved
Yeah.
that. So
I
let's
just
start with
did.
question number 3.
Okay, so the question is, can you go down? Because see what they're saying. Okay, wait, I opened it up on my laptop, the paper.
Okay,
Uh, so it's state Newton's second law of motion. So his second law of motion is that an object which is at rest or having constant velocity, it will remain that way
that actually
unless
the first one, that was the first law.
that's the first one. Oh, the second one is the force is it's proportional to the change
The
of
rate-
momentum, like
F
to the
equals
rate of
to.
change.
So you have to explain that F equals to ma concept, right?
So when
Or you can also
uh
explain with the reference of change of rate of change of momentum. So you can say that Newton's second law states that force is.
proportional to the rate of change of momentum.
So one possibility is to write a rate of change of momentum, or the second one is that we can simply explain force is directly proportional to acceleration and the direction will
It's
be in the same
constant.
direction of the force. Yes. So these are two concepts. It's up to you.
Okay.
And
Okay,
in this,
part
yes,
is use figure 3.2 to determine for the block at time equals 2 seconds the magnitude of the resultant force. Okay, so we know force is equal to wait, can you go up?
okay. So basically, you have to find the resultant force at time t is equals to 2 seconds.
Yeah, but we need like the block to see. Okay. So the block has momentum initial is 0, and then the final it like reaches 6,
Hmm.
and then it stays at 6 for 2 more seconds. But what they're asking us right now is
Hmm.
to find the resultant force on the block at time t equals 2. So at time t equals 2, you can see from the graph that the momentum is 3, right? 3 kg meters per second.
And in question for the block at time t is equals to 2 seconds, the magnitude of the resultant force. So
Yeah,
basically,
so if we know that momentum is 3 and time is 2, then we can find out force. Because force is impulse multiplied by time, right?
yes, or you can use the
Impulse
formula
divided by
one
time.
to, yes, the rate of change of momentum, right? So the values of the momentum and the time is given in your table, and you can see that from 0 to 4 second, a graph is like a uniform gradient, or the gradient
Yeah,
of the remains same. So it's up to you.
just
Either
divided by.
yes, 4 minus 0, the time period, and momentum will be 6 minus 0. So that will give you
Mhm.
the same answer, right?
Yes, okay, so 6 divided by 4 is 1.5.
Yes, and you will also get the same answer in 3 divided by 2. Okay,
Yes. Okay.
so it is 3, yes.
Okay. And then the second part of the question is asking us to find the force X. So the force X is the opposite of like the what's it called? Like it's the direction, the force being applied. So we have to add the what's it called? We have to add the resultant force with
Yes, the
what
force
the
effective.
force was, the magnitude, right? So it's 2 newtons. So 2 plus 1.5 gives you 3.5.
Yes, so we already know that surface frictional force is constant and has a magnitude of 2 Newton. And we already calculated the resultant force on the block, that is 1.5. So your total force will be,
3.5.
yes, 3.5 is your final answer.
Yeah.
And in graphical representation, you have to sketch a graph to show the variation of force X with time from time t is equals to 0 to time t is equals to 6 seconds. So basically, from 0 to 6. So from 0 to 4, you are having a constant force, right? Because the gradient
Yeah.
graph shows you the constant value between the momentum and the time. So the time period between 0 and 4 seconds gives you the constant value of the time, right?
Yeah.
After 4 seconds or between 4 and 6 seconds, the momentum of the body remains same, right? So basically, till
Yep.
4 seconds, you have to mark different position, and after 4 seconds, you have to choose different position, right?
Yeah.
So between 0 and 4 second, what is the time? Oh, sorry, what is the force actually? We calculated the force, which is equals to 1.5, and the total force is actually
3.5.
2.5. And what if we consider the final state? So at this point, you know that momentum is uniform, like between 4 and 6 seconds, momentum is constant. So what do you think? What will be the value of the force? Because there is no net force acting on the body, right?
Yeah.
So there is only force.
So it's gonna be like 2.
Yes, because this straight line shows you there is no change in momentum. So it means force remains same. That is the force of friction. And the gradient part shows you the total force is 3.5. So 3.5 and 2.0 Newton. If we consider on the graph, so 3.5
Yes.
till 4 seconds, and finally 2.0 after 4 seconds, right? Clear? Any confusion?
Yeah. So so this is like it, or do you have to draw the line?
Yes.
Okay, and the line has to be exactly like a straight line, right?
Because this only shows you the value of the force, and before or till 4 seconds there is a constant force acting, that is 3.5, and after that only force of friction 2.0 is acting, so again there will be a straight line. Okay, so
Okay.
it's also very simple. Okay, next part is related to density. So first of all, in the first part, they are asking, by using the definition of pressure and density, show that pressure is equals to rho gh. So basically, this is the proof for the equation that pressure in liquid is equals to rho gh. So if you remember how to drive this equation,
Okay, so
we
we
started
know that
concept of pressure.
pressure equals to
Area.
over area.
Yes. And then we know that we can also write a force as the work done. Work done over area, then mg over A, right? And what will be the final step to make the same equation rho g h? We have to use the second relation of density, because density is equals to mass upon volume, right? So if we shift volume on the left hand side, so density times volume is equals to the mass. So equation 1 can be written as pressure is equals to over A. Okay. And finally, you know that volume is also area into height. You can split the equation further and you will get your final answer. At the place of volume, we can plug in the value of the volume, area into height into G divided by A. Area will be cancelled out from the upper value and you will get your final equation. Rho GH. Okay, so this is the equation that you have to drive. Clear?
Yeah.
And next part suggests why the equation in A does not give the total pressure on the base of the beaker. You may take the reference from the diagram. So why this equation gives you the exact pressure on the base of the beaker? Because we only calculated the pressure in liquid, right? With this equation, we are only able to find pressure in liquid. Okay, this equations only help you to find out pressure in liquid. And you can see that a beaker is completely open. So there is another quantity of pressure which is applied on the surface of the water, which is known as atmospheric pressure, right?
Yeah. So we can do like,
So basically we have to add atmospheric pressure with the equation that we drive. Okay. So if we include the atmospheric pressure, so that will give you the final answer. Okay.
okay.
Okay. So in part B, we can easily identify that we have to add the atmospheric
Okay.
pressure
So I
because,
read the next part of,
okay.
yeah. So I read the next part of the question and it's asking to determine the density of the liquid.
Okay.
So we have to use we have to use what's it called, the formula, where it's gonna be the pressure equals to rho GH, because this is the liquid, right? We need to use rho GH. So we have to take the like the total pressure. We have to divide it by the what's it called?
The,
We okay, wait.
the
So the pressure 9.66 minus 9.6, then you multiply that by 10 to the power 4. It's going to be equal to rho multiplied by 9.81, which is the gravitational field acceleration, and you multiply it by 8. But not just 8, you're going to multiply it by 8 times 10 to the power of negative 2, because in the graph they gave you in centimeters, right? But you need to make it into the SI unit, which is meters. So you're going to multiply it by 10 to the power of negative 2.
yes.
Then to make the thing finished, like make your equation done and stuff, you can divide it by 8.0 times 10 to the power of negative 2 multiplied by 9.81 to get rho.
Yes, very good. So basically, you can easily identify that we have to use the same equation. Only we need to shuffle the equation, then we need to substitute the values. So you already find out the difference in the pressure, 9.66 minus 9.60 divided by the value of G. Again, we know that we take that value in meter per second square. So it means we have to convert height into meters, right? And this actually length is in centimeter. We have to take into meters. Okay. And after calculating all the things, what is your final answer for density?
For density, final is gonna be like,
And one more
wait,
thing, also exponent 4, right? So we have to include that one also. Yes. So now what is your final answer for density?
wait, let me solve it using my calculator because my calculator and my computer is kind of bad.
So your answer should be equals to 765.
Also, like, is there a range of answers for this question?
Basically, you just need to round off the value. You will get the value 764.5 or like something, and you just round it off to 765. That will be your final answer.
Okay. I got 764.5. So then you just, but
Yeah.
shouldn't you round it to like two significant figures? So like 770?
Yes, we can also round it off to two significant figures. So round off 770 will be the final answer. Okay. Kilogram meter cube. Okay. Clear.
Okay.
And then the D part is a solid cylinder is held stationary by a wire so that the base of the cylinder is level with the surface of the liquid. All things are given in the diagram. Length of the cylinder is given, cross-sectional area given, tension is given. The cylinder is now lowered and then held stationary by the wire so that the top of the cylinder is level with the surface of the liquid. So basically the top part of the cylinder is actually in the level with the liquid level, right? And now you need to calculate the new tension. Okay. Got the question what they are asking?
Yeah.
So because previously the upper part of the cylinder is over the liquid surface, then we immerse into the liquid and now both are at the same level. So we can say that now it is completely immersed into the liquid. And now we have to calculate the new value of tension. Okay.
Okay.
So for the forces, you can easily identify that weight of the object will act in downward direction. And what are the other forces acting on the body? One is the tension. So this is the old tension. Basically, we have to calculate the new one. So we just write new value of the tension. Okay. And is there any force that we have to add in the diagram or in our equation? Because we immerse that object into the water surface or into the liquid. So is there any force that we have to include in the equation? Otherwise, these two forces are equal and opposite. Do you think that we have to add any other force?
Um, like,
Force
don't
applied
you need to,
the upthrust,
yeah,
right? Because that will also act in the upward direction, the value of the upthrust.
yeah.
So your final equation is that new tension plus the upthrust force is equals to the weight of the body, right?
Yes.
And what you have to do now? So
Okay,
basically,
so what we have to do now is we know that the tension, we can use the force equals to, the Archimedes principle, right? The force equals to rho, gravitational field and the volume.
okay, so we have to find out the weight and the new force is unknown basically. So how to find out the value of the weight of the object and the value of the upthrust? So if we first find out the weight of the body, so weight is equals to mg. So mass is given or not? I think we calculated the mass somewhere. Density, no, mass is not given, I think. Yes, mass is not given. So what we need to do to find out the weight of the body? So first
To
of
find the
all,
mass,
yes, let's suppose
okay,
if we consider the weight first. So weight is actually equals to mg, and you know that mass is not given. So we just shuffle this value with the values of density, right? Because density is equals to mass upon volume, and we have to multiply these values. So your weight will be equals to density times volume into acceleration due to gravity. So this equation will give you the value of the actual weight, right? So we can easily find out the value of the weight from this equation. So what will be your answer?
okay, uh, so what we get to do is, you're gonna get 0.11 from the, what's it called for the other one, and then the tension is gonna be 0.53.
Okay, so for the weight density 70, right?
Yeah, 760.
We rounded off to 770, right? Or 765.
Like it was, we can just round it to 770 to be honest, because that's better. So 770 multiplied by 9.81 multiplied by 3.7 times 10 to the power of -4,
Hmm.
right?
Because
Multiplied by 4
of the
times 10 to the power of
so
-2.
multiply by area, yes.
Okay. You're gonna get 0.11 newtons. Like it's 11179, but we just rounded to 1. And then to find the tension, we know already that on one side it's 0.53. So 0.53 minus 0.11 gives you 0.42
Hmm.
newtons.
Okay, so you just find out the weight of the body is equals to 0.11. This calculation is equals to 0.11, right?
Yes.
Okay, and what about the upthrust?
Upthrust is 0.53 minus 0.11 gives you Like upwards is 0.13, right? And then minus 0.11 gives you 0.42.
Okay, so your final answer is 0.42.
Yeah.
Okay. Because now it is immersed into the liquid, so definitely the tension on the string will release, right? Because weight also helps the body to lift in upward direction, right? So that's why our new tension will be less than the initial tension. Okay, any confusion?
No.
Okay. Next is related to the waves. In the first part, state the name of the principal region of the electromagnetic spectrum for the wave. The wavelength is mentioned over there. Okay, so in this part, we have to consider the wave section. Length is given. Wavelength is equals to 8.4 exponent minus 6 meter, and you have to name the type of electromagnetic spectrum that actually lies in this wavelength. So what will be the wavelength and what is the range of the wavelength that you can identify? Either it is infrared, gamma, beta, or any other. So basically,
Okay, so 8
Mhm.
times 10 to the power of -6, it's gonna like fall into the region for the infrared because I memorized this. I memorized all of the wavelengths.
This is the range for the infrared, so that's why infrared is the name of the principal region. And in part 2, calculate the frequency in terahertz of the wave. So basically, you just need to calculate the frequency and then convert into terahertz. So frequency can be calculated with the simple formula, right? V over lambda. So this formula helps to calculate the value of frequency. Then we have to convert into T hertz.
Okay.
So you will get the answer of frequency equals to 3.6 exponent 13 hertz, right? And basically, if you want to convert into T hertz, so what will be your prefix? So actually that prefix will be equals to 10 to the power 12, and you are getting 10 to the power 13. So it means that if you just split into two parts, like this, right? So this will be your frequency. So we just need to write 10 to the power 12 as capital T, and rest of the part remains same. Or if the decimal in forward direction, so your answer will be equals to 36. Okay.
Okay.
Or finally, we can say that 36 T hertz, right? This will be your final answer.
Okay.
Next question, next part of this question is related to the young double slit. Quantities are given, diagram is given. And there are much detail given in this part. asking about the light waves emerging from two slits are coherent. State what is meant by coherent. So what is the meaning of coherent?
Coherent means when it has the same constant phase difference.
So you have to write. So when we are having a constant phase difference, so that term is known as the coherent one. And secondly, we're talking about the separation of the slits. So we have to calculate the separation of a slits, right? So what is the formula if you remember?
It's gonna be lambda equals to ax divided by d.
Yes. So actually we have to find out the value of A, right? And if we mark the values from the diagram, so the distance between the screen and the slits is equals to 2.8. This is capital D, right? And wavelength is given. A is unknown. And what about the value of X? So you have to identify the value of X by your own, because in your diagram, they just shows you this distance is equals to 22 millimeter. So this distance is actually equals to 22 millimeter, and PQR are the marks on the diagram, and the white space actually shows you the bright fringe, and that block is shows you the dark fringe, right? So PR
Okay.
shows you the dark fringe, sorry, the bright fringe. These are the bright fringes, and Q is the dark fringe. So you have to mark your distance between the slits by your own according to the diagram, right? So for that, you have to count the number of the bright fringes and number of the dark fringes between these 2 points, right? So let's suppose if we make the waves, if we start from this point, okay? So this is the pattern. So basically we have to count the numbers 1, 2, 3, 4, 5, 6, 8. So basically there are total 8 dark fringes, right? Between 22 millimeter. And how many bright fringes are there? Or you can simply say that, let's suppose if we have 8 dark fringes, and that is equals to 22 millimeter. So if we divide by 8, so you will get the length of one fringe, right? Clear? Because you know that
Yes.
the width of the dark fringe and the width of the bright fringe is same, right? And we have to only find out the value of X from this diagram. And if you got the value of the one fringe, that is X, so you can just simply manage to find out the distance between P and R, the distance between two consecutive bright fringes, right? Because we have to
Yep.
find this distance. So 22 divided by 8, what will be the answer?
22 divided by 8 is gonna give you
75
2.75.
minus 3 meter, because values are given in millimeter. So minus 3 for the milli, and 2.75 exponent minus 3 gives you the value in meters. And this will be the value of X, right? So finally, we just substitute all the values. Lambda is 6.2, exponent minus 7. These are the values that you have to use for your calculation for the value of A. Okay. So what will be your final answer for the value of A?
Okay, so it's gonna be 6.2 times 10 to the power of -7. I'm sorry if I'm not like talking that much today. I'm just a bit tired.
Okay, no issue. So basically, I'm getting this answer. You may cross check by your calculator.
0.3 times 10 to the power of -4. That's what I got.
Okay. And in part C, we have to calculate the difference in the distance. It means the part difference from each slit to the center of fringe Q. So Q is actually the center, and you have to find out the part difference. So basically, let's suppose if we again consider the diagram of the fringes. So this is the diagram for the fringes, and Q is the center part. This is the center part, right? And from the center part, you have to find out the distance part difference from each slit to the center of fringes Q, right? So what will be the distance from the each slit to the center? That is the question you have to find out. Okay.
Okay.
And previously in the statement they shows you fringe P is the central bright fringe. Okay. P is the central bright fringe of the interference pattern B. Fringe Q and R are the nearest dark fringe and the nearest bright fringe. Q and R, nearest bright, nearest dark, respectively to the right of the fringe P. Okay, so P is the basically the center. So we can just shift the center towards P. So this is the central value at point P, and Q and R are the nearest dark and the bright fringe on the one side. Okay, because on the Q you can see that that is the dark fringe towards the right hand side, and R is the bright fringe towards the right hand side that is nearest to the P. Okay. So let's suppose if you need to find out the part difference. So for the part difference, because P is the bright fringe and R is also the bright fringe, right? So between P and R, how much length you covered? Half wavelength, complete wavelength, 1/2, 3/2. What will be your wavelength? If you consider P and R, because P is your central bright fringe, and if you move towards right hand side at point R, you will get your first bright fringe, right? So at that point, your wavelength will be half, right? Because there is
Yeah.
only a dark fringe and one bright. So there are two consecutive bright fringes, but only one dark fringe. So it means one dark fringe is missing. So we are only containing half wavelength, right? So the part difference is equals to the half of the wavelength. So wavelength is actually given 6.2 exponent minus 7 divided by 2. So final answer 3.1 exponent minus 7, right?
Yep.
And finally, the phase difference. So any idea about the phase difference?
For the phase difference, can you go back up to the picture? Isn't it like either gonna be like 180 or like either 360 or 180?
Yes, so actually this will be equals to 360, right?
Okay, but how do we calculate that again?
Yes, because we know that if we start from P and then at R, you will take a complete round, so that will be equals to 360, right? If we start from the center and the next bright fringe you are getting, so it means the phase difference will be 360, right? This is the central part and this is the first order. So whole oscillation shows you the 360-degree change, right? So that will be equals
Yep.
to 360 degrees. Okay.